Yes, good morning, my dear students. So this is the second class in unit number 2, which is the requirements and design features of distribution systems. So distribution system objective is to supply a quality of power to the consumers. So to transfer the quality of power to the consumers, what are the essential requirements? That is the most important for us. So some physical requirements are required and some technical requirements are required. So let us consider all both that is physical as well as technical requirements are to be considered into account here. So in this regards, the general requirements and design features of distribution systems are physically the primary feeders, distribution transformer piece, distribution transformer, secondary distributors, service main and sub main, and consumer connection points. So these are the physical requirements to transfer power from substation to the consumer ports. So primary feeders which occupies are existing in between the substation to the distribution transformer, which is located near the consumer load areas, and distribution transformer piece where the distribution transformer is located. Before the power entering into the distribution transformer, the distribution transformer piece is to be provided to protect the distribution transformer. So distribution transformer is to be placed in streets we are observing. Some concrete beam is to be established, and on that beam the distribution three-phase transformer is to be placed. So distribution transformer here is a protective device for the distribution. Secondary distributors. So secondary distributors are from distribution transformer secondary onwards to the up to the consumer points. So service main and sub main. Service main is the electrical wire from the distributor to the metering point of a consumer. So consumer metering point onwards to different connections are given, that is the consumer connection points. So these are some physical connections or physical requirements for transferring power from substation to the load centers accurately. In addition to these physical requirements, some technical parameters also required for designing the distribution system. So in addition to above, some of the technical parameters such as proper voltage. So proper voltage, why you say proper voltage in the sense? So all the load appliances are to be designed for a single phase supply having a voltage rating of 230. So as long as the voltage is properly applied for the load appliance, so that it will give maximum lifetime. Otherwise, the component is to be spoiled as soon as possible. So as per the IEEE standards, a plus or minus 5 volts or 6 volts is hardly to be acceptable for any load appliance. But beyond that, the load appliance has to be reduces its lifetime due to inefficient voltages or fluctuating voltages. And second parameter is availability of power on demand. This is another technical parameter. And then reliability. Reliability in the sense continuity of the supply, quality of the supply. These are all comes under the reliability. You see here requirements and design features of distribution systems point of view. Primary feeders. These all are the technical. These all are the physical equipments, and these all are the technical. So let us discuss one by one here. Actually, good voltage regulation is the most important factor in distribution system for delivering good service to consumers. So for this purpose, careful consideration is required for the design of feeders. So feeders, let us see. So feeders. Feeders are located from distribution substation onwards to the up to the distribution transformer. The distribution transformer is located in load centers, and distribution substation is to be located outside the load center. So therefore, there is a connection which is required from substation to the where the transformer is located. So that is nothing but the feeder. Yes. So feeders are the conductors that connect substation to consumer ports and have a large current carrying capacity. So the nominal voltage of this is 11 kV. So it has a large current carrying capacity. So then only it will supply the load to the consumers. So the type of conductor is selected in such a way that the current loading is uniform along with its whole length. For example, a feeder carrying is 1000 amperes, it is having 1000 meters. So per meter length, 1 ampere is to be distributed. For example, the load is 2000 ampere, per meter length 2 ampere is to be distributed. That means that the current loading of a feeder is uniform along the whole of its length. Since no tappings are taken from it, the design of a feeder is based on current carrying capacity. So remember here, students, feeders are conductors which are connected in between the substation to the primary of the transformer, which is having a large current carrying capacity. So the current loading is also uniform along the whole of its length. So no tappings on this. Why? Because the nominal voltage is 11 kV. This voltage is not at all suitable for the consumers. So therefore, no tappings on this feeder. The design of feeder is based on current carrying capacity. And similarly, distributor. So you take the distributors. So distributor commences from after the distribution transformer, and these are goes along with the streets. So when the connections are required for the consumer, they are taking the nearest pole to the house to our metering point. So the poles carries the conductor which is known as distributors. So these distributors located very close to the consumer premises. So distributors are conductors. Distributors are conductors which run along a street or an area to supply power to consumers. So this can be easily recognized by number of tappings. Number of tappings means the distributor may having number of connections. For example, a distributor is going, 10 or 20 houses are there. All the houses are taking connections from the distributors, which are taken from them for the supply to various consumer terminals. So this can be easily recognized by number of tappings which are taken from them for the supply to various consumer terminals. The current loading of distributor is not uniform. That means that whereas in feeder the current loading is uniform, but in distributor the current loading is not uniform. Every meter length the voltage drop is to be changed. It varies along the length. It is not uniform, and it varies along with the length of the distributor. While its design is largely influenced by the voltage drop along it. So as per our discussion, so these are running in the streets. So the consumer taking connection from the nearest pole onwards to the metering points. So the voltage drops are varying from point to point. Why? Because due to number of tappings, and the current loading of distributor is not uniform. This depends upon the length. So well, its design is largely influenced by voltage drop along it. And similarly, service main and sub mains. So this term is very familiar. So the connection between our energy meter in our house to the nearest pole carrying a distributor, so that wire or connection is nothing but the service main. So these form the connection. This forms the connection between distributor and metering point. The sub main refers to the several connections given to consumers from one service main. So The pole nearest to your house onwards to the your metering point is the service main, and metering point secondary onwards the number of sub mains are to be going. Yes, so we are keeping a breakers in our house. So each room has one breaker. Those are known as the sub mains. So feeders, distributors, service main and sub main, these are the essential requirements. Transformers and transformer pieces are readily available in the market, so that we can purchase and initiate it for the supplying for consumers. So these are the physical connections for design of a distribution system. And while come to the technical side, so technical side requirements of good distribution systems are proper voltage, availability of power on demand, and reliability. So proper voltage is one of the most important power parameter, and availability of power on demand is also most important power. Consumers required electrical power. At that time, we have to supply the power. And reliability in the sense continuity of the supply, continuity and accuracy, all are comes under the reliability. Yes. So let us start from the first one, that is the proper voltage. Yes. So one important requirement of distribution system is that voltage variations at consumer terminal should be as low as possible. Yes. So why the voltage variations are taking place in the sense? Because of load variation. One consumer may be turn on the loads, one consumer may be turn on the loads. This process is continuously happening, resulting the load is continuously varying, resulting some voltage variations are to be taking place at the consumer point. Yes. So our intention is to keep these voltage variations as low as possible. So these variations are as low as possible so that the load equipment is protected. Yes, the load equipment is more safety. Yes, and some standards are there how much variation per load voltage is. So load voltage causes, for example, voltage may be over high, voltage may be low. What are the impacts here you can observe? If low voltage causes loss of revenue, inefficient lighting, possible burning out of motors. So these all are the generalized problems due to the low voltages. Whereas high voltages causes lamps to burn out. We are observing in our houses generally. Sometimes we are suddenly switched off, the light is to be broken. Why? Because at that time the voltages are high. Even switching cases also some lamps are burned. Switching is a transient condition. When switch is to be turned on, a huge voltage is to be developed, or huge currents are to be developed, and resulting the fuses may be burnout. Yes, high voltages causes lamps to burn out permanently and may cause failure of other appliances. The good distribution system ensures the voltage variations at consumer terminals are within permissible limits as per the IEEE standards, that is the plus or minus 6% of the rated value at the consumer terminals. One best example I will give for you. Suppose if you purchase a quality of Sony TV, maybe a 42-inch or 60-inch, whatever it may be, the cost is hardly 1 or 1.25 lakhs. Suppose if you keep in a operation, within 1 or 2 days, due to the fluctuations in the voltage, the TV has to be gone. But what is your feeling? So what is the importance of voltage? So voltage variation or voltage fluctuations is too much damage our load appliance. This is not at all acceptable. It is the responsibility of utility as well as the consumer to keep a stabilizers, all the things, so that you are protecting the load equipment. As per the IEEE standards, hardly plus or minus 6% of the rated value at the consumer terminals is acceptable. Beyond that, there is no possibility for the voltage variation. So therefore, design and requirements of a distribution system, along with the physical parameters, technical parameters plays a crucial role. That is the proper voltage is the one thing. Second one is availability of power on demand. You see here, availability of power on demand. One important thing here we can observe, electrical energy cannot be stored. Suppose if high power is there, you can store and you can utilize when there is no power. The facility is not there. When the consumer required electrical power utility, at that time power availability is required. Yes. So at that time the electric utility has to supply the power to the consumers according to their demands, according to their required times. Yes. So for this purpose, the utility what it has done, it observes the load curves daily, and then load is required. At that time they are supplying. Yes, power must be available to the consumers in any amount that may require from time to time. Electrical energy cannot be stored. Therefore, the distribution system must be capable of supplying load demands of the consumers. Yes, so it cannot be stored. Therefore, the distribution system must be capable of supplying load demands of the consumers. So this necessitates that operating staff must continuously study load patterns to predict in advance those major load changes that follow the known schedules. That means that what is the necessity here? The staff must predict what is the load changes based upon that, in which time is high load is utilizing by the consumers and which time is less load is to be utilized by consumer. So those all are to be calculated, and according to their convenience, they supply power to the consumers. And next one is reliability. So reliability in the sense continuity, quality, these are required. Yes, nowadays without electrical power you can't do anything. Modern industry is almost dependent on electrical power for its operation. Homes and office buildings are lighted, heated, cooled, and ventilated by electrical power. Yes, so the necessity of the electrical power continuously required for the consumer for all these appliances, so that we will provide interruptionless to the consumers, and quality of power to the consumers will give the high reliability of the consumers. Yes. So this topic simply concluded that this is the second topic of the unit number 2, that is the requirements and design features of the distribution system. So in this there are two parameters. One is the physical parameters, physical equipment. Another one is technical parameters. These two should very essential to make a quality of distribution system. So thank you. With this topic is to be closed. Thank you one and all.